how we processing the data, prepare the data. I have a whole list. Again, most of them are just to remind you what technique you could use, and later on, you learn just on time, or learn on demand. This is another time you try to remember everything later on in case you need to use it. And the opposite is true. When you need to use it, you're going to go to learn it. And I just remind you what kind of technique is there and the possible help. So run pretty fast, but the material is all prepared. Whenever you need it, you can just go to read it and get it. Or data cleansing, that's pretty clear. When you got all this reused data, it's not like statistics prepared by yourself, exactly what you want, and you are going to have to do a lot of things to clean it. And I'm going to talk about how do you discretize the data, just to make the data size smaller. And the data integration, that means smooth data. And the reduction, for example, how do you reduce the dimension? And the data transformation, kind of normalize the data and make it compare the apple and orange easier. There's a lot of mathematics computation. That's why that's a part of the math class. Or underneath is all math. What really matters to the computer is counting and then lookup. That's the two things. You know, any program in the end is a lookup table. You down to the tree and then you do the counting. So let's start data cleansing. When you gather those data, especially when I mentioned the medical data, you have a lot of missing data. How are you going to deal with that missing data? You have a lot of improper data. You can clearly know it's wrong. Somebody misinput digital and got a negative high, for example. And you need to detect and handling the outliers. And you handle the big noise, especially the instrumentation data from the instrument. So first, how do you deal with the missing data? Let me give you an example, simple. Like Steven, you collect all the real estate house prices, but sometimes you just missed a few houses. You don't know what's the value of it. And but it's important. You know, it's there, but you don't know the value, but you want to use the data. How are you going to treat this missing data? Well, you have some options. Delete it, right? That's one option, but not the best. Another option is you do an interpretation. Interpret it. How do you do it? Well, then you look now, one side is the rich community, another side is the poor community. This guy is right in the middle. That's easy, you average it. But if this guy is close to the rich community, you're going to give that a little more weight of the rich side because the dollars per square feet are different. Or if there's more close to the poor community, you're going to give more weight to the poor community. Have you heard this called the inverse distance, weighting interpretation? And you use the distance, reverse it, and then give different weight, right? That's one way to do it. How do you do it? Really depends on your training and your understanding. So, make sense? You need to weight according to the distance. Closing get more weight of that price, and the far get less weight. That's pretty simple. And medical data have the same problem sometimes. So how do you handle this inaccurate value? How do you handle that? So first, how you identify these outliers. As I said last time, sometimes the outliers is exactly what you're looking for, but sometimes this really produces a huge error. It depends on case to case, how you're going to deal with it. There's no one single way. Sometimes a typo could be you identified. You can only deal with the small data. So. and the measurement error, and the duplicate, noise. Those are. So what is irrelevant? That's your analysis. How do you know if it's irrelevant or relevant? That depends on what you're looking for. As I said, if I apply for a basketball team position, my height is relevant. But if I apply an academic job, my height may be irrelevant. So it really depends on what you do and you understand your data. Nobody can do a good job without understanding your own data. And because in the beginning, in the end, it really reflects your domain expertise. You need to stay in something you know makes sense. If it does not make sense to you, your model won't make sense to the computer. That's for sure. Because you want to, first you make sense, you define, make the computer to mechanically do it. Okay, the age of data. Can you give me an example? When it comes to data, the age is very important. Again, you need to give a different weight for the age of the data.
Stock data?
Huh?
Stock data?
Yeah, stock data. If you look at something 5, 10 years ago, it wouldn't make a big difference. But something 3, 5 months ago make a huge difference, right? So when you start to consider those factors, you might need to put the time stamp as a different weight, right? Sometimes just delete it. For example, in the signal processing, GPS signal, if the time stamp is too far away, you don't use it at all because it's not useful at all. So there are a lot of things. If you do a project, you might spend a lot of time just doing the cleansing and to make this meaningful data to you and eliminate all the useless things. What's the most efficient way to do it? I think the Microsoft Excel is the best. Sometimes you just click the whole column, delete it. Sometimes you merge a few columns, do an average. And I would think just if you are good in programming, MATLAB is what I recommend. And also R is very good. If you want another language for statistics and data mining, R is the best choice. And the MATLAB is almost as good, but it's not free. We have it free. I would suggest if you want, use the MATLAB Excel to do it. You can cheat a lot very quickly. That's what you did before, right?
Yes, sir.
Okay. Smooth data. What is a smooth data? Give me an example. If you got the IMU, inertial measurement unit, in your robot,